you. It's for Saigon. Huh? It's related. Towers of Hanoi is. Oh, really? Yeah, was a Vietnamese.
Hanoi is the capital of my country. I thought Blitman joked the other day when he said Tower of Hanoi.
No, it's a real thing. It's the fake capital of the country. People don't go there. They go to Ho Chi Minh City. That's where the airport is. That's where people go. What's this? Well, it's not the fake. It's not, well, they go to that airport, but that airport is named after the historical name of that city. Not, it became Ho Chi Minh City after, was it emperor? It was the emperor.
Do you know who is Ho Chi Minh is?
Yeah, it was, I just said it was an emperor of Vietnam. That's why a lot of the...
It's the first president of our country. You said emperor. I don't know what that is.
I did say it at the beginning. Was it emperor or king or whatever?
Okay, I don't get that word.
Leader of the country.
Then that makes no sense.
All right. So, questions on stacks and that kind of stuff.
For peak, what if you didn't say without removing? You just like displays the top of the stack. Is that like really important? Or?
I would say the without removing part is pretty important.
Okay.
If you just say displays the top of it and you didn't indicate that it's removed, I won't take points off.
Okay.
But it is important to make that distinction between peak and pop. That peak shows the top, pop gives you the top as well as has a permanent side effect to the stack. The stack has now been changed. It has a new top of the stack. All right, so that part is an important thing to have straight in your head. All right, so we're actually going to start a new project today, so I can, yeah, that way I can give you a good starting point for your homework assignment. And I'm extremely excited about. I'll drop a hint in the interface about halfway through class or so, and you'll love it. All right, now V has to pay extra special attention here because I'm going to create a new project and I'm going to put it on GitHub. All right, so we have to remember, I'll actually release it on GitHub right off the bat. Okay, I'll put it on GitHub right off the bat. So whenever you create a new project in Android Studio and you want to get that project onto GitHub, you have to follow the instructions I'm going to show you. If you're always forking my project and then downloading it, then that's you never actually have to go through this process. But if you are starting a brand new project and you want to put your project on GitHub, you're going to follow these instructions. All right, just going to start a new project, just like any old project. And we are going to call this guy, do I give too much of the, we're going to call this guy Visual Sorter. And I'll just hit finish. Not what I'm writing. All right, so I have a fresh project here. I'll go ahead and let Gradle finish building it. And let's just make sure, I'll hit play and make sure I get a nice little hello world application thing pop up. I think this is my version that I don't like. I like running on the Pixel. Oh, this is the one that's broken too.
Wait, that's upside down.
Huh?
It was upside down.
No, well, it might have been, but it's also corrupt. Here, I need to clean these things up here a little bit. Well, let me delete these couple of things. I want to get rid of this guy. Can I delete him? Apparently not, but this is the one I wanted. So I'll just go with this. There we go. That's the one I want. See, this one actually launches the OS. Yeah, if you ever have issues with Android Studio, something's not running well, just create a new emulator as a first step, just to make sure your emulator doesn't get corrupt or something. You know, I don't know if it's real common for them to get corrupt, but I leave mine open pretty often. I'm shutting my laptop and things like that, so I'm also switching between projects, so I run different apps from different projects on the same emulator, so it's possible I'm more prone to it crashing. But all right, so we have a working app here, so I'm going to go ahead and put this on GitHub now. So everybody paying attention? V, are you paying attention? All right, so we go up to VCS, which is version control. And I'm going to say import into version control. I'm going to say share project on GitHub. It's going to go ahead and name the thing for me back here. Let me make sure I'm on the internet. Yeah, I am. So if it's the first time you've connected your Android Studio to GitHub, it's going to ask you to log into your GitHub account. It'll actually probably make you do it twice. It'll make you do it through Android Studio, and then there's an integration piece for Android Studio to GitHub, so it'll like launch the GitHub website for you to log in. But you only have to do that one time. Log into GitHub if it asks you to log into GitHub. I'm already logged in. It went ahead and just gave my name as the same name of my project and just hit share. It automatically selects the stuff for an Android Studio project that needs to go onto GitHub, so you don't have to do anything special. So don't mess with the check marks, and just say okay. Notice it even puts the comment in there for the initial commit. You want to add the following lines. This is like an XML file. Just hit this checkbox, says don't ask me again, and just say yes. That way it always adds anything new you add to the project to GitHub. And it's on GitHub. Here's your link. There's the project on GitHub. So this is what you will submit for your homework assignment. Now, whenever you make changes to your project, that's when, well, I probably shouldn't have closed all those, but that's fine. It's the way the cookie crumbles, I suppose. Whenever you make changes, after you make a change, you've seen me do this before, you go up to VCS, you go to commit, you add your notes for what you changed, then you do a commit and push. So commit commits those changes to your local Git repository. Push pushes those changes to your remote Git repository, which is on GitHub, which allows you to share your code conveniently with me. Make sense? All right. So quick review for GitHub, so some of you don't have to keep submitting zip files, which I hate, because then I can't grade on my cell phone. Well, when there's a will, there's a way. I could, but I just give you a 0. It's easier that way. It's actually a good way to test whether a student cares. If you have like a student that you don't really get an impression that they're like engaged in the class or something like that, just purposely give them a 0 on a homework assignment and see if they squawk. If they squawk, that means that they care, right? They're upset about it. It's like, whoa, I turned that in. I worked for 5,000 hours on it. But if they never say a word, checked out. These are the things teachers do. They just screw with you. What's this? You never check. You never check them. Don't you get a notification when I grade something?
Well, the
You
Blackboard,
have
but
Blackboard
you don't have to. It's not annoying.
What's extra annoying, probably, we don't have a lot of paper. Well, actually, you probably get it for Bible study, or I'm sorry, not Bible study, Bible homework, because I read all the Bible homework offline, because I can like export a report, and I can read it and grade it on that. And then when I release the grades, it's a batch release. So like everybody gets their grade within like 2 seconds. Yeah. So, but sometimes when I get backed up, where you have like 3 Bible homeworks that I haven't got caught up on, I think I'm all caught up right now. But if you have a bunch of like, you'll get 3 grades instantly, right? Like as if I'm just turbo throwing them. Bible homeworks are actually fun to read because sometimes you get like really deep, good responses to something. I will comment on it, but sometimes you get some pretty funny So a couple people already turned in next week. So I didn't have one for this week because I was sick all last week and I put it up too late. So I just made it due this coming Sunday. But this week's some people have already submitted and I've been reading them. Some of them are pretty funny. So you're encouraged to have a good sense of humor when you write them, but not like irreverently, you know. It's you're still like responding to something you're reading in the Bible, but some of them can, you know, like this week's, can have a little flair associated with it, is what I'm saying. I was laughing pretty hard, actually. Okay, so let's go ahead and build our interface first. So I'm going to go up to my activity main thing here. I'll dump this guy. I really wish I could just change this to... Can I convert it? Oh, I can. That's so good. This is life-changing for me, people. So you know how I've told you I hate constraint layouts? But that's the default now. It used to be vertical linear layout was the default. So I can right-click on that guy, and then I can say Convert View, and I can say I want it to be a linear layout. Huh?
Can you pull that thing up?
No.
Can you explain what is those laid out for?
Well, I say Convert View.
No, but what are their functions? What is the difference between them?
I don't know about this coordinator layout. Relative layout is kind of like the predecessor to constraint layout. So relative layout says I want this button to be, 6 pixels down, 10 pixels over from this button. So you're placing views relative to other views. I never liked using it. Frame layout, I've definitely heard of it before. I'm not sure how it differentiates. I think it's probably kind of an approach similar to like web interfaces with like divs, where you kind of divide the screen up into various like frames, and then you can target individual frames, and probably a frame itself has its own layout. I'm not an interface guy, so that's the one we've been avoiding. Yeah, constraint layout is kind of the current way that apps, the layout for apps work, not just for Android, but also for iOS. Except iOS makes it, in my view, a lot easier to work with, but I've also put in an effort to learn it on there. I haven't put any effort to learn it on Android Studio. But what it does is it constrains your location of things to like the size of your screen, so that you can write an app once and have it look reasonable on like, a giant screen phone and a normal size phone and those kind of things. That used to be a big problem with Android. Big complaint with Android, because you had 4 zillion devices that all had little different sizes and different pixel densities, and you still do, but that was always a bragging point for Apple that they didn't have that, but now Apple has that too. Apple has several different phones that have different screen resolutions and stuff like that, so you no longer have that, like, well, all of the iPhones have the exact same screen size, so your app will look great on all of them. It's not as bad as Android, but it's not worth bragging about anymore, is the punchline. All right. Linear is easy. That's what I always put linear, horizontal or vertical. I did make it horizontal by default, so I'm going to immediately come in here and change the orientation to vertical. So now I have a vertical linear layout as my top level. This has really everything to do with, I'm not focusing on interface building in here, and I'm comfortable with vertical and horizontal linear layouts. So chances are, if you are going to write a professional, I just untied my shoe. That's fine. Chances are, if you're going to write a professional Android application that you want to run nicely on multiple devices, if it's a business app, you could probably get away with using a vertical linear layout if it's just kind of a utility, boring type interface. But if you want to have a fancier interface, it would probably be worth your time looking into constraint layouts and learning how that works. All right, but I'm not a designer, so this is my cup of tea, is the punchline. Okay, so now I have my nice vertical linear layout, so I don't have to worry about it constraining my vertical linear layout where our views look kind of funky. So now I just have a top level. It's great. All right, so I'm going to start putting some stuff in here. What we're going to have here is we're going to have an array that we randomly fill up with some numbers. And that's going to be on the left. And then we're going to have some buttons that allow us to sort that array. And that'll show us the sorted array on the right for testing. So I'm going to kind of lay this guy out. So at the top, I'm going to call this, I'm going to put a text view up here. And I'll put the text, what's the name of my app here? Visual Sorter. All right, and I'll make this guy a lot bigger, and I'll make him bold, I'll make him italic, and I'll make it center. We don't like italic.
I was gonna say make it underlined.
Oh, well.
Just get all of them done.
Just hit all the buttons. I don't think that just says all caps. There isn't an underline one. You blew that call, didn't you? All right, so we have Visual Sorter. Now we're going to have some buttons across the top here. So I'm going to put a horizontal linear layout in here. And I'll add my buttons to that guy. All right, so there's one button. There's two buttons. There's three buttons. My far left button is going to be called Reset. This button will be called Insertion Sort. Actually, we're just going to take the sort off so it fits. And then this button, which will be your homework, is going to be Merge Sort. Aren't you excited? You get to write Merge Sort. Just think about how much better or stronger of a programmer you are now. It's going to be so good. All right, so now, the idea is that so underneath here, I'm going to have another horizontal linear layout. And I'm going to put two list views in there. All right, and each one I'm going to give a layout weight of 0.5 to. I think this should. Oh, I need to make sure that this horizontal linear layout here, its height's not set to match parent. Its height is set to wrap content. Otherwise, it's pushing that last one off the screen. So default, when you put layouts in, the height is set to match parent. So its parent is this screen, right? So it pushed it all the way to the bottom, which means that this guy is shoved off the bottom. So I wanted to just wrap the height of those buttons. So I'll set the height of it to wrap content. Make sense? All right. Yeah. So the idea here is on the left, we're going to have our unsorted values, just have numbers. And on the right, we'll have our sorted values so we can kind of visually see these. So I'm going to go ahead, and so we're going to need to have access to both of these. So this left one I'm going to call unsorted LV. This right one I'll call sorted LV. So we're going to need array adapters for both of these. Now this kind of goes in line with what we were doing last class, where we have an interface and then we have logic behind the scenes. If we want to use our default array adapter works on arrays of what? What is it able to display by default? Arrays of strings, right? Or linked lists of strings, but we've worked with it with arrays of strings. Well, I'm going to have a collection of numbers. So when we actually go to display it, we'll probably be displaying an array of strings, and that array of strings will always mimic. It'll always be the string version of our array of numbers. Make sense? All right. So I'm going to start off by creating, I'll go ahead and hook these couple of guys up and create my two array adapters. All right, so I'll go ahead and I'm going to say private, and this is going to be a list view. This is sorted LV, unsorted LV. Then I'll have a private array adapter of strings. And this is going to be sorted AA, unsorted AA for our two array adapters. Then I'll have a private int array, sorted numbers, unsorted numbers. And then I'll have a private string array called sorted strings, unsorted strings. So my array adapter is always going to display my sorted and unsorted strings. But what I'll actually be sorting is going to be my integer arrays and then updating my string arrays accordingly. Make sense? All right, so now let's go ahead and grab a couple of these things. So let's grab our list views first. So I'll say this dot sorted LV is equal to this dot find view by ID r dot ID dot sorted LV. This dot unsorted LV is equal to this dot find view by ID r dot ID dot unsorted LV. So we've hooked those couple of things up. Now let's go ahead and instantiate our we need a couple of things here, right? We need our we need our arrays. So let's go ahead and build those. So we're going to say sorted, well, say this dot sorted numbers is equal to a new int array. Now, why don't I go ahead and I'm going to create a value for the number of elements. That way we can change it in one place if we want to change the number of elements. So I'll have a private final int, and we'll call this guy, actually it does support a constant, but I'll just call it a final int. Number of elements, and we'll start this guy off at 100. So we'll do 100 numbers. All right, so this guy will be number of elements. Final means that the value can't change. All right, so I can't, down here, I can't say this dot number of elements is equal to 200. Cannot assign a value to a final variable. Make sense? So that guy is so that's the end. All right. So there's this dot sorted numbers is that guy. This dot unsorted numbers is equal to new int array, this dot number of elements. Then I'm going to do the same thing with my sorted and unsorted strings. This dot sorted strings is equal to a new string array of this dot number of elements. This dot unsorted strings is equal to a new string array of size this dot number of elements. So now all four of those arrays are capable of holding the same number of elements. There's no elements in there yet, okay, but it's capable of holding the identical number of elements. All right, so now I want to build my array adapters. Now array adapters, remember, take 3 parameters. What are the 3 parameter types for an array adapter? They take a context. What's the job of an array adapter? What does it do? just generically speaking, answer that question. Don't forget about the parameters for a second. What is the job of an array adapter?
Displays a string array.
Okay, displays a string array. So it adapts a collection to a view. So we can show it on the screen. Right, that's what it does. Here's a collection of, here's my string array, collection of strings, and I want this guy to be displayed inside of a view. All right, so we already have the context thing, which is kind of the outlier. That's the weird one. What are the other, if you are the constructor for ArrayAdapter, if you're an ArrayAdapter and your job is to adapt a collection of strings to a view, what are the two pieces of information you're going to need? Yeah, so you need a collection and a view, right? You need those two guys. All right, so we don't have our row collection yet, so we need that one that's just a text view. Remember that guy? So I'll go into resources here. I'll go into layout. I'll right click here. We're going to create a new layout resource file. And for the root element, we're going to set this guy as a text view. That's going to be the root element of that dude. All right, and what's this?
What does it mean by the root element?
Like the root element by default on our layouts up to this point have been constraint layouts, and now we want them to be vertical linear layouts, but for a simple, it's whatever the top level view is. So that's the root element. So constraint layout has been the default root element for all our layouts. That's what was in here as the default, but this one we actually want it to just be a text view. No layout to it, just a text view. So root element will be a text view, and we're going to call this guy our simple list view row. Make sense? That's a simple list view row, just a text view. All right, so there we go. We got our text view, and I'm going to make the font a little bit bigger so I can read it. All right. And we're going to go ahead and actually we don't even need to give the guy a name. It's fine. It knows how to work with it. So that's our row. So we'll come back into our main activity now. We're going to go ahead and set up our array adapters. So this dot sorted AA is equal to a new array adapter of type string. And it wants the context, so the context is going to be this activity. It wants my view, so this is r.layout.simple list view row. And then it wants my collection. So the collection I'm going to pass this guy is I need to give him a collection of strings. Make sense? Okay, so my collection of strings here is called this dot sorted strings. So I want that list view, my sorted list view, to show a collection of strings. Similarly, my unsorted array adapter will be a new array adapter of type string, and context will be this. Layout will be r.layout.simple list view row, and he's going to display this dot unsorted strings. Everybody cool so far? All right, so that's what that guy shows. So now we have our array adapter. So now we need to marry these array adapters to our list views. So this dot sorted LV dot set adapter to this dot sorted AA. I don't know why this put a weird space in there. I'm sure I put the weird space in there. And then this dot unsorted LV dot set adapter to this dot unsorted AA. That makes sense? All right. So we kind of have our interface set up now, but we actually don't have anything inside of our array of strings yet. Okay. I actually wonder, because it probably put default value, so I bet you it gives me a list of 100 empty strings, but it could actually crash. Let's just test out of curiosity here, because we haven't filled up our arrays with any data yet. But they technically do have a size. crashed. All right, so now we need to put some data into these guys. All right, so I'm going to create a private void. Let's call it fill int array. Well, I'm going to call it fill random int array. And this guy will take an int array as a parameter. And his job is to fill that guy up with random numbers. Okay? Now, in order to do random numbers, what class am I going to need access to? Random class. Where does the random class live? Anybody remember? Go ahead. Java.util. So now I can just come in here and I can just say random r is equal to new random. And I can let it go ahead and import it. So it says, oh, it's going to actually want to put it into here. Let me start it from the beginning part of it then, so it imports it. So I'll say random, and notice it says java.util there. If I just press enter, it went ahead and imported it for me up here. There's my java.util random. Now I have access to that library. Okay. So inside here, I'll say random r is equal to new random. I'm going to go through every element of AR. How many elements are in AR? Technically, yes, but if this is your entire worldview right now, yeah, AR.length. So this is my entire worldview. My number of elements in AR is AR.length. Okay, so I'm going to say for int I is equal to 0, I is less than AR.length, I plus plus. Remember, we're writing this guy to be generic, so we do not necessarily know that somebody's going to pass an array in here that was built using number of elements, or that was hard-coded with 100 or 50 or something like that. But we have a way of asking this guy, how many buckets do you have? And that's AR.length. Make sense? All right, so we're going to go ahead and we're going to fill this guy up with some random numbers. Do we want it to be, r.nextInt by default. So if I say AR at bucket I is equal to r.nextInt, that's going to give me a number in what range? No, just this guy right here. What does r.nextInt give me? No, but that's what a lot of languages do. A lot of languages have a random number generator that gives you a floating point number between 0 and 1. That's not what rand.nextInt does, especially since it's an int, not a double or something like that. But this gives me a random number in the range of all integers. And what's the range of an integer? How big is an integer? Huh? You do know. Remember way back when we introduced the primitive types and we said we have byte, short, int, long. Bytes are 8 bits, shorts are 16 bits, ints are 32 bits. So what's the range of values that can fit into a 32-bit number? Well, 31 is part of the answer. What'd you say?
Is it 200 something?
No.
Just kidding.
Is it negative 2 to the 31st to 2 to the 31st?
Yeah, ish, because it's actually encoded in something called 2's complement, which we'll talk about in 325. But so it's roughly negative 2.1 billion to positive 2.1 billion. That's negative 2 to the 31st power to positive 2 to the 31st power. All right, so we probably, though, want to use another version of nextInt that gives us a bound. So if I say, give me nextInt, let's say 500, this will give me numbers between 0 and 499 inclusive, or 0 and 500 exclusive. That make sense? So it gives me a little bit more normally looking numbers. So at a glance, we can we feel like, you know, these, we can read them instead of having these giant scary numbers. All right. So this guy will go ahead and fill up our random array of integers. Then we're going to have another function, private void copy int array to string array. This will take an int array, AR ints, and a string array, AR strings. And its job is to overwrite all the elements of that string array with the string version of the contents of my AR, my integer array. And we can presume for this guy that these guys have the same length. All right, so we're going to go through every element of my string array. How many elements are in the string array? AR ints.length, yeah. So for int I is equal to 0, I is less than AR ints.length, I plus plus. We want to then put into AR strings at the same bucket the string version. I want the string version of bucket I of AR ints. How do I convert an integer to a string? All right. So if I say AR ints at bucket I, it's not right. So were you giving her props? You were giving her props, weren't you? Did you know or did you not know? See, now he's playing dumb. What kind of animal is this? It's an int. It's an int. What kind of type is an int? Is it a primitive type or is it an object type? Primitive type. What are primitive types? You should, this is from 200 people. We've all had 200, right? What are primitive types? Not what are the primitive types. The primitive types are byte short, int long, Boolean. Only the numeric types. Boolean holds true and false. Chars technically hold unsigned integers. What's the generic definition of a primitive type? So stuff from 200 not important anymore? The foundations of programming is unnecessary, really. If we're going to go and become a professional programmer, we don't need to know that. Primitive types are types built into the language that can only hold a value. Only hold a value. Which means that he wouldn't have a toString to call. Right? Because an int only holds a number. It holds a signed 32-bit integer. I love that idea. Okay, so what we can do is we can take that int, whatever it is, and just concatenate it onto the empty string. Now we got the string version of that dude. Make sense? Java's just, go ahead.
Could you use there's a util for arrays, and you can do arrays to string?
Well, possible. Let me look. Arrays.toString. Now this guy returns a string type, not a string array. So what he must do is he takes an integer and basically concatenates all the integers in there, just gives you a string. So I mean you could do that, it just wouldn't give you the type of thing you want. All right, so we'll go through every element of AR strings. Well, we'll fill up every element of AR strings with the string version of the equivalent bucket in AR ints, overwriting what's currently in AR strings. Because AR strings is the guy that we're currently displaying, right, in our list views. So we want that guy to just mimic the look of our two integer arrays. All right, so I'm going to go ahead and fill up one of my integer arrays. Now, the other integer array, well, actually what we could do is we're going to have them both be jumbled right now. So we'll fill up one of our integer arrays, and then we're going to copy that array. All right, and let me just look here real quick so I can introduce that to you. Arrays dot wish it would show me the whole thing here. Ah. Oh, no, that doesn't. I mean, this would pull off what I want, but I have to do it at the top. So we're just going to write our own. Yeah, we're just going to write our own. So we're going to say private void copy contents of int arrays. This guy will take in an int array AR1 and an int array AR2, and we're going to copy everything from AR1 into AR2. So for int I is equal to 0, I is less than AR1.length. You could also say AR2.length because we're presuming these guys are parallel arrays. They're arrays of same size. I++. We'll say AR1 at bucket I is equal to, actually we want to copy AR1 into AR2. So actually let's call this guy source and destination instead of AR1 and AR2. So we're going to say destination at bucket I is equal to source at bucket I. So we'll copy the source into the destination. So when this guy is all said and done, now why can I have this guy return void, but expect destination to now be filled up with all the elements from source? What can you tell me about these parameters that would make that work? This function returns nothing, right? It's void. Yet I'm going through the motions of going through every element of source, copying the value from there into the same position in destination. And I expect that to have a permanent change. Why is that change a permanent change? Okay. Yeah, arrays are passed by reference or passed by address. So these guys come in as addresses. So when I make a change to destination, I'm changing the actual place in memory. Okay? So this will copy the contents of my array. So I'm going to go ahead and fill my unsorted int array. So I'll say this dot fill random int array, and I'll pass it this dot unsorted numbers. So that's the array that I'm going to, that's my initial numbers, right? Then I'll go ahead and say this dot copy contents of int arrays, and this guy takes my source followed by my destination. So the source is this dot unsorted numbers. My destination will be this dot sorted numbers. Okay. Then I want to fill my string arrays to mimic the int arrays. And what will I do there? I'll say this dot copy int array to string array, copy int array to string array. So I'm going to go ahead and I'm going to copy this dot unsorted numbers to this dot unsorted strings. What's this guy complaining about up here? Oh, thank you. And then this guy is going to be this dot copy int array to string array of this dot sorted numbers to this dot sorted strings. Now, every time we make changes to our int array, we need to redo these two lines. So what I'm actually going to do here is I'm going to say private void update string arrays. And I'll actually just put those two lines in there. And then in here, we'll just call this dot update string arrays. So whenever we need our string arrays to get updated, we'll call this guy. And then what we'll do inside of update string arrays is we'll also then say this dot sorted ArrayAdapter dot notify dataset changed, and we'll go ahead and just do it for unsorted as well, even though we're not really going to be changing unsorted. We'll just notify him anyways. Like, look, I just made some changes potentially to your dataset. Just letting you know, update your list view. Make sense? All right, so now I should have a list view filled up with some random numbers. So here's currently our unsorted, and then this is our sorted one, but it's currently not sorted, so it's just showing the exact same thing. So the idea is that when I hit insertion or hit merge sort, it's going to sort this guy and show the results over here. Make sense? But we want our reset button here to effectively initialize all the values. So what I'm going to do here is I'm going to write a little private void initialize arrays. And I'm going to have this guy effectively do what I did right here. So this guy's going to fill int array, copy the contents of that, update the string arrays. So there's my initialize arrays. Then I could have my reset button just call that function. So I'll have a public void reset button pressed UV. This dot initialize arrays. So you made an appearance in the code. You give me crickets. I named a variable after you. This is one step short of people who buy people named stars. Oh, you just noticed that? I mean, this is like equivalent of like Picasso, like, you know, just dropping like a, you know, somebody's name in the middle of one of their paintings, like it is an obscure thing. You gotta like know it's there. It's like an Easter egg. But what do you mean? This is like a sign of respect. Variables named after you. See, rude would be if we were using Swift, which lets us have emojis, and I pick some like Vietnamese emoji or something like that. That would be rude. This is respect, V. I can change it to Blaine if you'd rather me change it to Blaine. You don't want it. Oh, yeah, seriously. Maybe we should make it Austin since he skipped today.
Return function, that's Luke.
Yeah, I didn't even notice Luke was missing. That's how forgettable he is. Because he's short, so he hides behind V. All right, so reset button press. This guy's just going to go ahead and call initialize arrays again. And what does initialize arrays do? It refills the int array. copies the contents over to the other int array, and then updates the string arrays, which then resets the list views. So I'll go ahead and hook that guy up. That is my, oh, that's my simple one. This is this guy. Reset on click, reset button pressed. I'll hit play. And then if we're not happy with our original set of stuff, we can just reset it and get a new set of stuff. Right? All right. So now we're going to call insertion. And then we'll review how merge sort works for your homework. Oh, man. So excited. And if you cry during the weekend, I want video. So this is going to be public void insertion sort button pressed UV. All right, so this guy is going to perform an insertion sort on the unsorted array. All right, this guy's going to do an insertion sort in the unsorted array. So we're not actually going to change our sorted array because that's going to show us the original state of it. So I'm actually only sorting the unsorted array. So I'll go ahead and I'll write insertion sort as another function here. So I'll say private void insertion sort. And this guy will take in an int array AR as a parameter. And this guy will say this dot insertion sort, passing it this dot unsorted numbers. Okay, but now after he does that, he needs to say this dot update string arrays. After he sorts it, he needs to update the string arrays. Make sense? And I'll go ahead and give you the button, public void merge sort, button pressed, UV, perform a merge sort on the unsorted array. And I'll write a private void merge sort int array AR. And this guy will call this dot merge sort int array AR. I'm sorry. This dot unsorted numbers. And then this dot update string arrays. Okay, so now let me go ahead and hook up those buttons. I'm going to get rid of I'm going to close the simple list view thing because that's going to keep confusing me. So I'll click on insertion. On click, here's my insertion sort button pressed. And here's my merge sort. Merge sort button pressed. Now, right now, both of those buttons call the appropriate functions, but the functions don't actually do anything, which means they don't actually change the arrays, but we're going to still reset the views. So let's go ahead and write insertion sort real quick. Remember, this is the one that has the follower, or the follower, that we start at bucket 1, and then we bubble stuff to the top as far as we can go, and the follower follows. Didn't we have, like, in our notes, we had a little skull and crossbones or skull guy for that? Isn't that it? So we'll just write that real quick. That way I have time to review merge sort for you. So I'm going to go ahead and I'm going to say for int curse start is equal to 1. Keep going as long as curse start is less than ar.length. Curse start plus plus. And I'm going to have an int called the follower. I'm also going to have an int called, call it swap, for helping me do the swaps. All right, so first thing I'm going to do is I'm going to say the follower is equal to curStart. And then I'm going to say while the follower is greater than 0, so as long as I possibly have a guy before me, and AR at bucket the follower is less than AR at bucket the follower minus 1. If both of those things are true, keep swapping, right? So what will we do? We'll say swap is equal to AR at bucket the follower. Then AR bucket the follower is equal to AR bucket the follower minus 1. And then AR bucket the follower minus 1 is equal to swap. And then the follower follows. So this guy will take the follower and move him up the array as far as he can go until we've either hit the beginning of the array, where we don't even have a do before us, or we finally hit something where the current bucket is not less than the guy before me. So we shouldn't do a swap. After this while loop ends, we just move up to the next version of curStarts. We move to bucket 2, set the follower to bucket 2, bump that guy as far up we can, then we go to bucket 3, set the follower to bucket 3, bump that guy up as far as we can, so on and so forth. So this guy will update my whatever int array was passed in here, and the int array we're passing in is my unsorted numbers. So we'll go ahead and run this. So there's my unsorted numbers, call insertion sort. Oh, did I fill the wrong? I made it sorted, but I meant this guy to be the did I put him in the wrong order? Oh yeah, unsorted is the first one, sorted is the second one. I didn't label them, so it's still a legal interface. So there's my insertion sort. Okay, so for your homework, you're going to make this merge sort button work. All right, so I'm going to remind you how merge sort works. All right, first of all, we remember recursion, right? Recursion is when a function calls itself from within itself. Okay, I'll just give you a quick recursion example. So we'll say private int factorial. That's usually our, it's like factorial. 5 factorial is 5 times 4 times 3 times 2. So as an example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Or we can say that 5 factorial is actually 5 times 4 factorial, where 4 factorial is 4 times 3 factorial. 3 factorial is 3 times 2 factorial. 2 factorial is 2 times 1 factorial. And 1 factorial is 1. That's where the recursion stops. So in here, 4 factorial, we'll say if, this guy takes a number, if n is equal to 1, return 1, else return n times this dot factorial of n minus 1. So that's factorial, recursively. This is a function that calls itself from within itself. All right, and merge sort requires this type of thing. So that's just your, I'll put a little comment here, recursion refresher example. So make sure you understand how that guy works. So now let me remind you how merge sort works. Because this is what you're implementing for your homework. So for your homework, all you have to do is get this function correct. You might find it handy to write a couple of helper functions. Hint, hint. All right, so merge sort starts off with an array. I'll do it on a simple array like this. And this guy is currently unsorted. I'll take these arrows out of here because they kind of represent our linked lists. And this is not a linked list. We could do it with linked lists, but that'll just overly complicate things. So here is my array. So merge sort operates off of the concept of being trivially sorted, where a list containing one element is by definition sorted. All right. So we're going to keep track of a couple of pieces of information here. We're going to keep track of begin, and we're going to keep track of end. All right, now these guys this is bucket 0, this is bucket 1, this is bucket 2, this is bucket 3. Okay? So the first question we ask is this array trivially sorted? It's not, because it has a length greater than 1. What does that mean? End minus begin is greater than 1. Okay? Or end and begin are not the same value. You can say that as well. All right? So, since this is not trivially sorted, what do? We call merge sort on half of it. Now, really, we're passing the entire array to merge sort. But what we're doing is we're saying we're only going to focus on the first half. Is this guy trivially sorted? Begin and end different numbers? So it's not. So we're going to call merge sort on the first half, where we'll go ahead and snuggle begin and end up on each other. Is that guy trivially sorted? Yes. Then we bounce back and we call merge sort on the second half. Is that guy trivially sorted? Yes. So this call to merge sort now ends. So we've had two calls of merge sort end. The one that took the front half, which begin and end were the same. We just said there's nothing to do here. These guys are already sorted. And then we took begin and end on the second half and said there's nothing to do here. This guy's already sorted. So those two calls to merge sort, we call merge sort twice, are now over. So now what we need to do is we need to perform the merge step on these two. So we create a temporary array of the correct size. And we're going to have two starts. So this will be start 1, start 2. We ask ourselves, which value is smaller, the value at start 1 or the value at start 2? Value at start 1. So we copy that here. And then start 1 increments. Which is greater? The value, well, which is smaller? The value at start 1, which is in a legal position. We're off the end of his half of the list. Or our only other option, which is start 2. Start 2. So we get our 7. Then we copy the contents of this temp array over the original array. So we overwrite the 5 with a 5. We overwrite the 7 with the 7. Okay? And that works because this was passed by reference. So we're changing the original array. So this guy is now done. Our original call has now, the first original call is now finished. And now we call merge sort on the second half. Just push these guys off to the side here for a second. Is this list trivially sorted? Nope. We'll call merge sort on the left half. Is this guy trivially sorted? Yep, it's one list. Call it on the right half. Is this guy trivially sorted? Yep, it's a one list. Bounce back up. We perform our merge step. We have start 1, start 2. We give ourselves a temporary array of the right size. Which is smaller, start 1 or start 2? Start 2. So that's the 2. So we copy that guy into the first bucket here.
The buckets at still 0 and 1.
Yep, this is our temporary array. So temporary array has a size of 2 because that's the size of our half. So we increment start 2. Which is smaller, start 1 or any legal position? Start 2 is off the end of our list now. So start 1 wins by default. There's our 3. Copy these values back over. So the hint here is this guy's from bucket 0 to 1. This guy is from bucket begin to end, which happens in bucket 2 to 3. Okay, so these indexes do not match each other. So we'll copy the bucket 0 here into bucket 2 there. The bucket 1 here into bucket 3 there. And keep in mind that that then makes a change globally because we passed by reference to the original array. So this guy is now done. This call to the second half is now done. Now we do a merge on the original. We have start 1. We have end 1. Ooh. We give ourselves a temporary array. Why is that doing that? Oh my gosh. Zero these guys out. This is start 1. This is start 2. The beginning of our first and second halves. I'm sorry, it's up here. Start 1, start 2. Which should come first, a 5 or a 2? A 2. Increment start 2. Which should come first, a 5 or a 3? A 3. Increment start 2. Which should come first, a 5 or the illegal position? The 5 comes first. Increment start 1. Which should come first, a 7 or an illegal position? 7. Increment start. We're now done. Because we made changes, then we copy the results over from this array to this array. So that's a 2, a 3, a 5, a 7. This merge step is done. And there's our original array sorted. All right, so make sure you follow this last like 5 or 6 minutes of the lecture closely to understand how merge sort works. You cannot write a solution to something without having an understanding of the problem you're solving. 2 calls to merge sort. Okay, 2 recursive calls. If it's not trivially sorted, you call merge sort on the left half, and you also call merge sort on the right half. The call to the right half will not happen until the call to the left half is completely finished, which means it's made a whole bunch of calls. All right, so I'll push this. I'll push the changes here. So your homework for Tuesday: write merge sort into that function so that it sorts that code with merge sort. Make sense? All right, I will see everybody on Tuesday.
The worst situation is that we
won't have homework
worst
over
situation
next
is that
week
we're
and
gonna look at
pack
two
on.
materials.
Correct.
Okay.
Find it.
I actually don't have that.
And remember, if you have not signed up for the hackathon, you need to get that done like today, because I'm getting ready to make teams here like soon. So email joshua.locklear@cuw.edu.
And it's with authentication, correct?
Correct.
All right, then. Not open yet. Let's do it. Brand new stuff. Content.
Oh, did you check your time for Saturday?